So we are discussing about p block elements. In p block elements, we are discussing about chemical properties. In chemical properties, hydrogen compounds we discussed. Next, halide compounds are we are discussed. Next, third one, oxides. Say, suppose in 15th group you take. In 15th group, so what are that? Nitrogen. So nitrogen versus oxygen. So this is the highest electronegative. So it is -2. So these are showing nitrogen +1 is there, +2 is there, +3 is there, +4 is there, +5 oxidation states. So that's why it is forming N2O, N2O2. This is you write as 2NO. Next N2O3, N2O4. This you can write as 2NO2. Next N2O5. So when nitrogen combining with oxygen, you are getting these things. This is you called as nitrous oxide. Famous is laughing gas. Next, this is nitric oxide. Say dinitrogen trioxide, nitrogen dioxide, dinitrogen tetroxide, dinitrogen pentoxide. So this. So in these first two are neutral. These three are acidic oxides. So if you see the structures, so N2O. So N2O structure, nitrogen, one lone pair, three single electrons. Another nitrogen, three single electrons, one lone pair. So that's why this is N2O. So what will be the hybridization? Here one sigma, here one sigma. So that's why number 2. 2 sigma bonds means sp. So it is between these two. Next, here you can write here what? Positive, here negative. Otherwise, another possible structure, the negative charge is coming here. So it will go to this side. So you are getting N double bond N double bond O. So the negative charge is coming, positive as it is, here negative charge. You are getting two lone pairs. So these two are the structures of N2O. Next, NO. So nitrogen, you take one lone pair, three single electrons. One oxygen is taken, two electrons. So you are getting single electron. So because of this single electron, it is showing paramagnetic nature. Next, here NO. NO has a single electron, another NO has another single electron. So both are combining. So you are getting N2O2 as a dimer. So there is no unpaired single electron. So that's why it is showing diamagnetic. Next, NO2. See, nitrogen, you take one lone pair, three single electrons, one O, second O. So coordinate covalent bond or dative bond. So here one pair unpaired single electron. So it is showing paramagnetic and it is showing brown color. See, suppose NO2. NO2 has a single electron, another NO2 has a single electron, both are combining. So you are getting N2O4 as a dimer. And it is showing diamagnetic because of single electrons are combining. Next, N2O5. So here N2O3 we are not discussing. So you take N2O3. So you take two nitrogens. another nitrogen. So here N2O3. So one oxygen is given, one oxygen combining here, another oxygen is combining. So that means N double bond O, N double bond O, both are connected, one lone pair, one. So this is unsymmetrical. Symmetrical means N double bond O, one lone pair, O, N double bond O, one lone pair. So this is a symmetrical compound, this is an unsymmetrical molecule. Next, N2O5 structure. So nitrogen, 2 electrons taken with oxygen, one lone pair is donated to another oxygen. Next, N double bond O, this one. So plus minus, plus minus. So two coordinate covalent bonds are present in this. So here solid N2O5. Solid N2O5 is observed as NO2 plus and NO3 minus. So this is also very important. So actually N2O5 is a covalent molecule, but it is existed in solid form because of these cation and anion to the strong attractions. It is available as a solid form. Next, some important points here. It is NO is paramagnetic, colorless. Next, NO3. NO3 you are taken means it is a diamagnetic blue color. Next, NO2. NO2 is a paramagnetic and it is showing brown color. So very important, these three. Next, say non-metal oxide. Non-metal oxide react with water. You are getting oxo acids. See, N2O3 react with water. You are getting HNO2, 2 moles of HNO2. Next, N2O4 react with water. You are getting HNO2 plus HNO3. Nitrous and nitric acid. N2O5 react with water. You are getting 2 moles of HNO3, nitric acid. Say N2O5, these are called as N-hydride. N-hydride of nitric acid. So in nitric acid without water you are getting this one. So N2O4 is called as a mixed anhydride of nitrous and nitric. N2O3 you called as anhydride of nitrous acid. Next, in 15th group only. In 15th group nitrogen is over. Now phosphorus versus oxygen. See, already here it is what highest electronegative. It is -2. Phosphorus is what? We have 2. Plus 3 is there, plus 5. Plus 3 is ground state, plus 5 is excited state. So phosphorus plus 3, oxygen -2. You are getting P2O3. But in the nature, phosphorus is available as P4 atoms. So that's why that is P4O6. Next, P plus 5, oxygen -2. 5 is coming, 2 is coming here. So you are getting P2O5. So here phosphorus P4. So you are writing as P4O10. This structure is also very important. P4O6. So for phosphorus you write down in tetrahedral form. And everyone is combining with oxygens. This is P4O6. Next, P4O10 structure. 4 phosphorus. You write down in tetrahedral form. Every one phosphorus combining with oxygens. Next, double bond O, double bond O, double bond O, double bond O. This is a ground state molecule. This is excited state molecule. Next, phosphorus also non-metal. So non-metal oxide combining with water, you are getting oxoacid. So that P4O6 treated with water. So lowest oxidation state, your answer is H3PO3, phosphorus acid. Next, P4O6, you treated with water. You are getting H3PO4. So in the balancing, 4 phosphorus. So you take 4. So that is 6H2O. So everything is balanced. Next, 4 phosphorus, 6H2. So try to balance that. That is ic acid, as acid you are getting. Next, 16th group. 16th group oxides. So you are taken sulfur. Sulfur versus oxygen. So highest electronegative -2. This is showing +2, +4, +6. So this is ground state. This is the first excited state. This is the second excited state. So S plus 2, oxygen -2. 2 to cancel, you are getting SO. S plus 4, oxygen -2. So you are getting SO2. S plus 6, oxygen -2. So you are getting SO3. See, suppose you see the hybridization and structure of these things. SO, 2 atoms only. No need to think about hybridization. So that is a linear structure. Next, SO2. So sulfur, you take a 6th group, 6 electrons. Next, 1 O, double bond O. So 2 sigma bonds, 1 lone pair. 2 plus 1, 3. 3 number means sp2. Sulfur you take central, write down 3 bonds. 1 is a lone pair, double bond O, double bond O. So you are getting V shape, or bent, or angular. So bond angle is less than 120. That is SO2. Next, SO3. So SO3, sulfur, 6th group, you write down 6 electrons. In that, 1 O, second O, third O. So 3 sigma bonds, 0 lone pairs. So number is 3. 3 means sp2. So by seeing the 3, you write down 3 bonds, double bond O, double bond O, double bond O. So you are getting trigonal planar. Bond angle is 120. Next, SO2 is also showing polymeric nature. SO2 is showing polymeric nature. SO3 also showing polymer. So that is a trimers. So dimer, trimer, tetramer, like that polymer structures are you are getting. Non-metal oxide. Non-metal oxide react with water. You are getting oxoacids. Suppose you take SO2. SO2 plus water. You are getting H2SO3. So sulfurous acid. SO3 plus water. You are getting H2SO4. Sulfuric acid. SO3 you called as anhydride of sulfuric acid. This is. Now you come to 17th group. 17th group oxide. So already halides we discussed. So that is 16th group halides nothing but 17th group oxides also same. So here fluorine, 17th group of fluorine versus oxygen. Already we seen. So what you are getting? F2O, F2O2. So these are used in rocket fuel. Already we are completed in last class. Next, now you take chlorine. Chlorine versus oxygen. So in fluorine versus oxygen, this is -1, this is positive oxygen. But here what? Oxygen you are getting negative, chlorine gets a positive. So here, how many positives of chlorine is there? Chlorine +1 is there, chlorine +3 is there, chlorine +5 is there, chlorine +7 is there. It is ground state, first excited state, second excited state, third excited state. If you see these things, structures, so Cl2O, Cl2O3, Cl2O5, Cl2O7, you are getting the compounds. Next, some other than this, you are getting special also. Cl2O4 is nothing but ClO2, also possible in the middle. Cl2O6, nothing but ClO3, also possible. So these two are, you remember, these are additional. So according to oxidation state, these are here. So you try to remember that also, that is possible actually. So Cl2O, how to write that? So two chlorines. So here oxygen is the central atom. This is a Cl2O. Next, Cl2O3. Cl2O3 means chlorine and chlorine. Here 7 electrons actually. So here one oxygen, here one oxygen you take. 3 is over. 2 lone pairs. Next, here what? Unsymmetrical you take. Cl2O3. So symmetrical you want means chlorine, double bond O, lone pair, middle one oxygen, next chlorine, double bond O, 2 lone pairs. That is a Cl2O3. Next, Cl2O5. So chlorine, 2, 1 lone pair, 1 chlorine. So 3 oxygens. This is unsymmetrical. You want symmetrical means chlorine double bond O, 1 lone pair, single oxygen, chlorine double bond O and lone pair. Next, Cl2O7, chlorine. So 3 oxygens, middle 1 oxygen, chlorine. So 3 double bonded oxygens. Next. So ClO2. So ClO2 take 3, 4, 5, 6, 7. 1 O, second O, 1 pair, 1 electron. So here 2 sigma bonds. 2 sigma bonds, 1 lone pair. So 3. 3 means sp2. 1 lone pair is there. So that's why you are getting V shape. Bond angle less than 120. Because of unpaired single electron, it is showing paramagnetic. So ClO2. ClO2 has a single electron. Another ClO2 has a single electron. Both are combining. So you are getting Cl2O4 as a dimer. And it is showing diamagnetic. So similarly, ClO3. ClO3. So chlorine 1, 2, 3, 4, 5, 6, 7. 1 oxygen, second oxygen, third oxygen, 1 electron. So because of unpaired single electron, it is showing paramagnetic. So 3 sigma bonds, 0 lone pairs. So that is a 3 number. 3 number means sp2. So trigonal planar structure, bond angle is nearer to 120. Next ClO3. ClO3 has single electron, another ClO3 has single electron, both are combining. You are getting the Cl2O6. It is a dimer and showing a diamagnetic. Next, 18th group oxides. See, in 18th group, xenon only forming compounds. That to be with one fluorine, another one is oxygen. See, if you see the xenon is showing +2, +4, +6, +8. With oxygen, -2. So, you are getting the compounds XeO, XeO2, XeO3, XeO4. In the nature, these two are not available. These two only available. See, because of, if you see, positive charge increases means the size is decreases. Xe +2, large size. Next size decreases. Next size decreases. Next size. So you are coming to here. These Xe +6 and Xe +8 sizes are close to oxygen. So that's why these are existed. So if you see the structures of XeO3. So xenon 1, 2, 3, 4, 5, 6, 7, 8. One oxygen, second oxygen, third oxygen. So 3 sigma bonds, 1 lone pair. So 3 plus 1 is 4. 4 means sp3. So xenon you take central, write down 4 bonds in that. One is lone pair, double bond O, double bond O. So the structure you are getting a pyramid. So bond angle is nearer to 107 degrees. That is XeO3. Next, XeO4. So xenon, you write down 8 electrons, 4, 5, 6, 7, 8. One oxygen, second oxygen, third oxygen, fourth oxygen. You are getting 4 sigma bonds, 0 lone pairs. Number is 4. 4 means sp3. So xenon you take central, write down 4 bonds. 4 out of 4 sigma bonds. So that's why the structure is coming as tetrahedral. Bond angle is nearer to 109 degrees 28 minutes. Okay, these are the oxides of P block. 15th, 16th, 17th, 18th also we are completed.